Right, so today we are going to look at the multiplexing of two 7-segment LED displays using the pic18f25k20 microcontroller. Now, this could be done in a number of ways. We could actually even use 7-segment driver on that circuit, but I chose to use one port, port C, and two other pins from port B to help with the multiplexing scenario. If we look here, we realize that we have successfully done the task at hand. You realize that one LED shows number 6 while the other one shows number 7. Again, all this is just optical illusion since only one LED is on at any given time. So how are we going to do that? But before we actually begin building this circuit, we may actually want to, let's say, simulate it, see whether or not it works. So we use Proteus to help us with that task. So let us now just zoom on the area in which we feel we will want to show the circuit. This is just a markup that I've already done, the circuit. If you notice, we've got two LEDs, 1, 2, which will basically give us the same scenario as we had with the actual circuit we just created. We use these two transistors here to basically drive the LEDs, or the displays, sorry, because we know that the amount of current which we actually get from our ports is basically limited. So if we want the proper brightness, we would like to have a little bit more current going in there. Again, as I said, the microcontroller that we're using is the pic18f25k20 microcontroller, and we're using that microcontroller to basically drive the two LEDs. Again, as I say, this is one of the circuits which does not necessarily require microcontroller, but again, we'll just use a microcontroller just because we can use a microcontroller. So now, how are we going to program this? The pic18f25k20 microcontroller comes on the Amicus 18 IDE development board, and it is programmed using the Proton Basic compiler programming language. Right? So here, let's open the Amicus IDE so we can have a look at what we're actually doing. Right. So here, as I said before, we are declaring port C as our output port because this is the port which actually drives the LEDs 7-segment. This port C is actually the port which is actually driving or sending the information to tell which LEDs to turn on or to go off. As you notice here, you see that we've got LEDs. These LEDs are in the off while these are on, right? And we want to send that information through the microcontroller. Right? We ignore this because that's your task to actually incorporate some form of an up-down counter in your program. So you notice this is just two symbols here for button up and button down, right? Which you in turn will have to modify in order to get this up and running. Okay. We created some variables, right, which would allow us to store the values after we have decoded it, because again, since we are creating our own 7-segment display driver, so to speak, we are going to decode that driver. So here we see that when we use the percentage sign in front here, we're actually saying that we are using binary. It's actually binary coded, right? We're to use, for example, the dollar sign, then this would have been hexadecimal, etc. Right? The tedious task of decoding the LEDs have already been done, right? Using your datasheet for your specific LED 7-segment display, you would have to perform that task for yourself. If you notice, the decimal point is generally left off. You will see it on in that case here, but it's not really connected, so it doesn't really matter. I could actually put it 0 over here, it doesn't really matter. Right? Now number 8 is the number where you see all your decimal, or sorry, all the LEDs are actually on in that scenario. Now we go to the main program itself, which we could see here, we're just looping in a number of times, continuous loop. So we've got while 1 equal 1, and then we end our while loop here. Created a function down here, or subroutine, sorry, where we will display the values on one LED, then the next LED. Right? So how are we going to do that? First, we need to set the what's going on here. And sometimes things happen. Right? So first thing you need to do is to set the to load our 7-segment values. We've got 2 arrays, alright, one which already contains, that we have already preloaded with all the decoded values, and we've got a counter which counts from 0 to 9, right, because we are actually doing decimal count. If we wanted to go hexadecimal, we would have changed this value from 9 to 15, if you notice 15 goes all the way to F, right, and likewise down here. Right? Now this value would just be, these changes allow us to go from 1, and then when it goes, when it gets to number 9 of the count, to go to the next number. What we have happening now is that we're telling the other display to start counting. Right? So we have started counting, we say, okay, well, this one is at 0, when it's at 0, we're going to load a value to it. Right? So we load the value for 0, which would be whatever that decoded value is. Then we say, let's now go to the next LED, right? Because we're counting from units, tens. If we had another LED, it would be hundreds, etc., etc. Right? So this next one we're saying, well, when you get to 9, upon going back to 0, this value now will change to the next value in the chain. Right? Basically how we count. I mean, this isn't something that has to be explained to you in detail. What seems to be, or you may have to understand a little bit more here, is this set of codes. Right? And we're just telling it to cycle for 0 to 20. You could have changed this value to anything that you wanted. But the important thing is to tell one LED or one 7-segment display to turn off while the other one, or to turn on, sorry, while the other one is off. Right? So a high says that we're giving it a positive value, or plus 5 volts, plus 3.3 volts, whatever the case may be, or 1, and low be our 0 potential, ground potential, whatever it is that we're telling it to stay off. So we're telling this one to be on while this one is off. When that happens now, we're saying that the value contained in the first segment, whatever it has in there in that array, we're going to send it to the output pins of our microcontroller. Right? And we're going to tell it to stay there for about 10 milliseconds. Then what we do is we rotate, we tell whichever pins which were on before and whichever ones which were off before, we're going to invert that and change the values there, and then tell it that we want the second 7-segment display value to be sent to the output pin, delay that for 10 milliseconds, and we're going to cycle that for a number of times. Alright? Once that has been done, we basically compile this program, right? And we realize that the value now will be saved, and it also creates a hex file. This hex file we use with our Proteus board. If I was to, for example, double click on our microcontroller right here, it should pop up, and you will see that I had choice of using either the .as file or the hex file, but I found that I have more success using this property. Right? Now, something that we need to pay close attention to is that simulations sometimes don't give us exactly what we want, but they tell us more or less whether or not we're on the right track or not. Alright? So what we're going to do now is to look at the simulation, and we're going to see whether or not we have anything that looks remotely like what we want. Alright? Now, one of the reasons why I'm saying that is because we may end up with the situation where the simulation software does not run in real time, and as such, you get a lag in your response. Alright? So we're gonna try out the program right now and see what result we may achieve. Alright? So we're gonna run the simulation, and hopefully now we should start saying something. Alright, so we realize that one comes on while the other one is off, which is essentially what we wanted happening. But remember I said that it's not happening in real time. Alright, so what you're seeing happening there is very slow, but remember we're programming for like 10 milliseconds. 10 milliseconds, we should not have been seeing these little gaps in the switching. Alright? There you can see essentially that the program itself is doing what it should be doing. Alright? You may be seeing one or two little inconsistencies here, but pay no big mind to that. Alright? Now, your task is to add the two buttons, the up down buttons, and to get these two babies, right, to start counting. When we press the up button to move from the number 0 to the number 99, or anywhere you stop along the line. When we press the down button, it decrements. In other words, whatever the value was, we'll -1 from it. Alright, so that's the task that you have. This is the circuit, or some form of the circuit, that is. The values may need some tweaking since they were not really so calculated, so to speak. Good luck, and thanks for participating in the class.